For 10,000 years, the rhythm of human existence barely shifted. Generations of families woke up, picked up wooden tools, and repeated the exact labor of their ancestors. Every ounce of food grown, every piece of fabric woven, and every stone moved relied on the physical strength of a human or a draft animal. By 1750, the pinnacle of steam technology was the Newcomen pump. It was a massive iron machine used to clear water from coal mines, but it was so inefficient it burned nearly as much energy as it produced. Global poverty during this period was a physical certainty. A society powered entirely by muscle is strictly limited by the biological output of its workers. In 1763, the University of Glasgow asked a 27-year-old instrument maker named Joachim Newcomen pump. He focused his attention on why the engine wasted 80% of its heat through constant cooling. Watt realized the machine would be more efficient if the cooling happened elsewhere. The addition of a separate condenser allowed the primary engine block to stay hot continuously. Coal consumption dropped by 75%, while the mechanical power of the engine tripled. These efficient pumps allowed miners to dig deeper into the earth, providing a flood of cheap coal. That fuel, in turn, powered a new generation of mechanical looms that could weave fabric hundreds of times faster than a human hand. By successfully moving the burden of labor from muscle to steam, Watt's redesign severed the biological limit that had defined humanity since the first campfire. Between 1750 and 1850, quiet market towns like Manchester became massive manufacturing magnets. The population grew from 18,000 to 300,000 as the horizon filled with brick factories and coal smoke. To keep these machines running, factory owners utilized cheap labor on a massive scale. Children as young as 5 worked 14-hour shifts, their small hands reaching into machinery that could easily kill an adult. This rapid growth saturated the environment with waste. London's River Thames became an open sewer, so toxic that Parliament was forced to suspend its sessions. While cities struggled with pollution, the steam locomotive began shrinking the human experience of time. A trip from London to Edinburgh that once took 2 weeks by horse now took 12 hours by rail. Output further accelerated with the division of labor. Adam Smith noted that while one man might make 20 pins a day, an assembly line of 10 people, each performing one specialized task, could produce 48,000. The progress of the 19th century carried a heavy cost, treating both the natural world and the human worker as raw materials for the machine. This chart shows the macro-level result. After 10 millennia of near-zero growth, global economic output tripled between 1820 and 1900. Similarly, in human health, long-term industrial wealth saw life expectancy rise to 78 years, with child mortality plunging to 4%. As mechanized farming and mass production provided the base requirements for survival more efficiently, human energy shifted toward more complex pursuits. The surplus of resources allowed individuals like Charles Darwin to dedicate decades to observation, resulting in theories that redefined our understanding of biology. Similarly, the demand for industrial problem-solving allowed Michael Faraday, the son of a blacksmith, to spend his life investigating the invisible laws of electromagnetism. This transition marked a shift in the human condition, where the focus of the species moved from securing immediate subsistence to investigating and mastering the natural world. The momentum started by James Watt never plateaued. The era of steam transitioned directly into the second revolution of electricity and steel. That foundation of power and precision engineering eventually made modern computing, global automation, and artificial intelligence possible. We are inhabitants of an ongoing, compounding process. The system that enabled 8 billion people to share this planet is the same one producing the environmental and technological risks we now face.